Hi, in this section we're going to cover inverse functions. Much of this information comes from the free online textbook College Algebra from OpenStax, and I have the website listed through my presentation so you can get that and use it for a resource if you'd like. It corresponds to section 3.7, inverse functions. So I want to start by discussing some of this stuff in this box here. So the first thing is that in order for something to have an inverse, it has to be one-to-one. So for any one-to-one function, the following holds. Again, it has to be one-to-one in order to have an inverse function. So this and this is read F inverse. It looks like a power, right? It looks like an exponent of -1, but it's not. When it's used in this way, it means the inverse function. So it's F inverse. Lastly, the important thing is that not all functions have inverses, and that is because not all functions are one-to-one. So one-to-one functions will have inverses, but functions that are not one-to-one will not have an inverse function. The first thing we want to be able to do is we want to use function composition to verify that f and g are inverse functions. The statement prior to the directions, to determine if two functions are inverses of one another, you're going to verify that f of g of x is equal to x and that g of f of x is equal to x. So basically when you compose the two functions together and you simplify, you're going to get just x. So let's see if that is the case here. So f of g of x, if we do it this way, we're plugging in g of x everywhere we see an x in the f, and you're going to do it both ways. It doesn't matter which way you do first. So -3 times x minus 5 over -3 plus 5. So this is like a -3 over 1. And so the -3's will cancel out. And so at this point, we will have x minus 5 plus 5. The -5 and the +5 cancel out, and we just have x left. So that is a good sign. We're trying to verify that these are inverses. We want to see that we have just x when we compose the two functions. So now we're going to do it the other way, g of f of x. So we're going to plug f of x into the g function everywhere we see an x. So we're going to have -3x plus 5 minus 5 all over -3. So the parentheses here aren't really necessary. So it's -3x plus 5 minus 5 over -3. So the first thing we can do is cancel out the opposite 5s here. We have a 5 and a -5. That's going to give us -3x over -3. And then the -3's cancel out and leave us x. So again, we got just x. So we can see that those are inverses. By composing them both ways and getting x, we're verifying that f and g are inverses of each other. Okay, so the next part, in order for a function to have an inverse, it must be one-to-one. It's important that you verify this if the information is not given. So in your homework, if it tells you that it's a one-to-one function, you don't have to do anything, you just go ahead and find the inverse. If it doesn't tell you though, you have to make sure you realize, well, is it a one-to-one function or not? You have to verify that somehow for yourself. So for this first one, this is y equals x plus 5. That's simply a linear equation, so it's a line. And a linear equation is a one-to-one function. Remember to check to see if it's one-to-one if you know the graph. It has to pass the horizontal line test. If you draw a horizontal line and it only passes through the function once, and that's true for every horizontal line you could possibly draw, then it is one-to-one. So no matter where I draw a horizontal line, it's only going to pass through this line exactly one time. So it's 1 to 1. If you have a 1 to 1 function, then you can find an inverse by doing the following. So to find an inverse, and this is if you're given a function, first you're going to switch x and y. Then you're going to solve for the new y. And then you're going to rewrite your answer in inverse notation. So write using f inverse. Okay, so number 2, we have y equals x plus 5. That's our original. All I did was replace the f of x with the y. So now what I'm going to do is step 1, I'm going to switch x and y. So where there was a y, now I'm going to put x. And where there was an x, I'm going to put a y. That's step 1. Now step 2 is solve for y. So I want to get y by itself. So I'm going to subtract 5 from both sides. And I'm going to get y equals x minus 5. So now I'm done with step 2. And now step 3 is I want to rewrite using f inverse of x. So the y is now going to be replaced with the inverse. So the inverse of f is x minus 5. So that's the inverse. Let's look at number 3. So for number 3, I'm going to do the same thing. If you remember your toolkit functions, this is some kind of a reciprocal function, which is 1 to 1. So you can know that. Just make sure you remember your toolkit functions and whether or not they are 1 to 1 or not. You can reference that as you work through these. So first I'm going to rewrite the equation as is, just with the y instead of g of x. Okay, so now the first step is to change my x's and y's. So now I'm going to have x equals 2y plus 3 over 5y plus 4. Now it's time to solve for y. So first thing I want to do, I clearly do not want to have a fraction. So I'm going to multiply both sides by the denominator. So 5y plus 4. And what that does is it cancels out the denominator on the right hand side, so I won't have a fraction anymore. And I'm going to distribute the x on the left. So what I will end up with is 5xy plus 4x on the left and 2y plus 3 on the right. Now, in order to solve for y, you have to get y by itself. In order to do that, you need to get all of your y's together. So my next step is going to be moving everything with a y to the left-hand side of the equation. So I'm going to subtract 2y from both sides. Everything that does not have a y, I'm going to move to the right-hand side. So I'm going to subtract 4x from both sides. So now everything with a y will be on the left, and everything without a y will be on the right. So I'm going to get 5xy minus 2y is equal to 3 minus 4x. Now notice that there is a y in both terms on the left. That means I can factor out a y. That means I'm dividing it out of each term. So that will leave me 5x minus 2 is equal to 3 minus 4x. By factoring out that y, notice that I only have one y now. As before I had two y's. That's an issue. So the way you're going to get this to be one y, kind of consolidate it, is you're going to get everything with a y on the same side and factor it out. That will always be your method when you have multiple y's like that. And now the last step is to get the y by itself. So since it's y times that factor, I am going to divide both sides by that factor. So if I divide by 5x minus 2, that completely cancels out. So it divides out to 1, so I just have y equals 3 minus 4x over 5x minus 2. And then the last step is to rewrite this using your inverse notation. So instead of a y, we're going to put f inverse of x is equal to 3 minus 4x over 5x minus 2. And that is our inverse. So obviously this one was more complicated than the last one, but the idea is the same. Okay, the next part of this section is we might be given a graph and we'll need to find function values and values of the inverse as well. So here, when you're talking about an inverse, as you saw from the previous examples, the last two examples, in order to find an inverse, we're interchanging our x and our y. An inverse function, all the x's and all the y's interchange. That's how it works. So, let me just use some blank space up here and do another example. Let's say I had a set of ordered pairs, and the ordered pairs are 1, 2, 3, 4, 5, 6, and 7, 8. Okay, so this is my function f. Okay, so f is the set of ordered pairs. We can see that it is a one-to-one function. It's one-to-one because no y values repeat, and it's a function because no x values repeat. The inverse is going to be when I interchange all the x's and the y's. So that means I'm just going to replace the x and the y values with each other. So instead of 1, 2, now my ordered pair in the inverse is going to be 2, 1. The next ordered pair would be 4, 3. I'm simply changing them around. 6, 5, and 8, 7. That is all that you're doing when you have an inverse. You're changing the x and the y values, okay? So when you have a function or an equation, you're simply switching the x and the y variables and then solving for y. When you have ordered pairs, you're switching the x and the y numbers in the ordered pair. That gives you the inverse. So different relationships, right? They just flip. So for this one, if I'm telling you that the x and the y switch or change places, that will help us with number 6 and number 7. So first I want to look at 4 and 5. Number 4 and number 5, we've done these before. So find f of 0. Keep in mind that this is f of x. So the 0 is in the place of the x. So if x is 0, what is y? Y will be 3. So the answer to this one is 3. Number 5, we have solve f of x equals 0. So this is in the place of y. So now it's saying if y is 0, what is x? Right here, x would be 2. Okay, so x would be 2. Okay, now remember, inverse is the opposite. So this graph is for f. This graph is for f. So normally f inverse of 0, that 0 would be in the x spot, but since it's the inverse, we're going to look on the graph for the y. So when y is 0, x is 2. This is the same as number 5. So 6 and 5 are asking the same thing. It's given to you in a different way, but it's the same information. Number 7, we have f inverse of x equals 0. Okay, so this is normally a y, but in this case, this is the x value because we're dealing with the original x function, the f function. So if x is 0, y is 3. Okay. This is the same as this. Okay. So it's the opposite if you're dealing with the other function. Okay, so since we're trying to find an F inverse and all we have is an F, we're going to use the opposite letter. So I like this graph. I think it helps a lot. In words, the range of a function f of x is the domain of the inverse. So remember we said the x's and the y's change. The domain is the x values and the range is the y values. So the domain of f is the same set as the range of the inverse. So the domain and range are exactly the same when you're looking at the inverses. The range of your original function is the same as the domain of the inverse function. It's the same exact set. Those are the same. I want to go back to my ordered pairs here. Notice that the domain of the original function of f includes the numbers 1, 3, 5, and 7. And the range of my original function includes the numbers 2, 4, 6, 8, because the domain is the x values and the range is the y values. So now let's look at the blue. The domain for the blue, the x values, are 2, 4, 6, 8. The range, 1, 3, 5, 7. Okay, so what I want you to notice here is the domain of the black is the range of the blue, right? The domain of your original is the exact same set as your range of your inverse. Same is true for the range of the original and the domain of the inverse. The same set. You're interchanging your x and your y's, so that makes sense that those are the same. That's what this graphic is saying. All right, so evaluate or solve, assuming the function f is 1 to 1. So if f of 6 is 7, then find the inverse of 7, f inverse of 7. Here's your x, here's your y. If this is your y, then your x is 6. So 6 and 7 go together. In the inverse, it'll be 7, 6. Number 9. If f inverse of negative 2 is negative 1, find f of negative 1. It's just backwards. Now this is going to be negative 2. Okay. All right, so now I want to look at the graph of the inverse function. The graph of the inverse function is the graph of f of x when it's reflected about the diagonal line y equals x. They call it the identity line. So the dotted red line is what it's reflected over. Remember that what you're doing is you're interchanging your x and your y's. So I want to kind of look at that as well. Our original function is this f of x function. Let's pick out some points on that. We have 0, 0, 1, 1. It looks like 2, 4. So for our f function, we have 0, 0, 1, 1, and 2, 4. Those are some ordered pairs. Those aren't all the ordered pairs, those are just some ordered pairs. For our inverse function, let's pick out some points there. We have 0, 0. If we switched out those, it's the same, right? Then we have 1, 1. That would be the same. And then we have 4, 2. Let's see if that's the same. We have 1, 1, 4, 2. That would be on the inverse graph. So these two things are inverses. They're reflecting across this diagonal line because the x and the y are switching places. So we need to use that information to answer some of the following. So let's say we have this graph of f. The first thing we want to do is see if it's 1 to 1. It will pass the horizontal line test. No matter where we draw a horizontal line, it'll only pass through once. We can also see that this looks like one of our toolkit functions. It looks like the square root function. So is this graph 1 to 1? Yes, because it passes the horizontal line test. So now we want to sketch the graph of f of negative 1. So I am going to draw my little identity line here. So this is going to be the line it reflects across. So it should be a mirror image. If you fold this graph diagonally up along that line, it should look the same. Well, it should look like a mirror image, not the same. Let's find some points. So I think that's kind of the easiest thing to do. So 2, 0 is a point. 6, 2 is a point. So 2, 0 and 6, 2. So those are 2 points from F. So now I want to find some points on F inverse. Well, if I know 2, 0 is on F, then 0, 2 has to be on F inverse. And if 6, 2 is on F, then 2, 6 has to be on F inverse. So I'm going to plot those. So 0, 2 would be here, and 2, 6 would be here. And if I want to make it look like a mirror image, if I draw it like this, then it looks like a mirror image of that f function over the red line. So that's number 11. So if you want to draw a sketch of an inverse, find some points, ordered pairs on your original function, and just switch the x and the y values, draw those on your graph, and connect them in a way that makes it look like a mirror image over the identity line. All right, number 12, find f of 6. So here, 6 is in the x spot, so f of 6 is 2. Okay, now find f inverse of 2. You can do this in 2 different ways. One way you can do it is use this 2 as the y value in your original f function. Or you can say, hey, I have the graph of the inverse, so you can use that as your x value for your inverse. Either way, your answer is going to be 6. Notice that these are opposite values, right? You have 2, 6, 2. If you have a 2, then you have to have a 6. Those go together. Okay, and then state the domain and range of f. So we're only looking at the blue, the f line. The domain is left to right, so it starts at 2 and then it goes to the right forever. Your range is bottom to top. It starts at 0 and goes up forever. And now we want to do the domain and range of the green, or the inverse function. That's number 15. So the domain of number 15 is left to right, so it starts at 0 and goes right forever. Notice that your range of your original function and the domain of the inverse are the same. That is a good sign. That's what's supposed to happen. Your range, that's bottom to top of your green, your inverse function. It goes down to 2, and then it goes up to infinity. Again, notice that your domain, your domain of your original f function is the same as your range for your inverse function. That should happen every time as well. Hopefully this helps out and gives you a little bit of a overview of these inverse functions. The last part that we have in this section is finding values, function values given a chart. So here we have f of 3. So notice we have the x value and we have the f of x. We are not given the inverse values, so we're going to have to use the chart in relation to the x's and y's given here. So this is like a y value, this is like an x value, and this is for f. Okay, so if we have f inverse, it's going to be the opposite. So for number 16, find f of 3. So 3 is in the place of x, so I'm going to look in the x column, find 3, and the associated y value is 4. So the answer is 4. For number 17, I've got f of x equals 5. So 5 is in the y spot. So I'm going to go to the y column and find a 5. I'm going to look in the x spot and I'm going to see that's 6. So x is 6. All right, now number 18 and 19, we want to know information about the inverse. Keep in mind, we don't have an inverse up here, so we're going to use the opposite value. So ordinarily, this is an x. So for the inverse, we want to look at y. So when y is 6, the x value is 5. So that's what we have there. Okay, notice this corresponds to number 17. And then for number 19, again, we have an inverse. So this is normally a y. Since we have to use the regular x function, we're going to say it's x. So we're going to go down to 8. We see the corresponding y is 9. So for the inverse, that would be the x value. So 9. So that gives you kind of a overview of this section. Here is the reference material. If you have any further questions, you might want to check out the textbook at that website.